Hello everyone, welcome to today's session. Let us start by giving you all a quick brief on what Octanet is. So, Tech Octanet is a budding startup headquartered in Bhubaneswar, specializing in IT solutions across diverse sectors including e-commerce, real estate, automation, and personalized business application. Our primary focus is to provide affordable services to startups, aiding them into their digital initiatives. In addition to our core services, we are expanding into the corporate training sector, aiming to equip future corporate employees with a solid foundation. We also address student needs by identifying academic project requirements, internship opportunities, and offering comprehensive solutions. We are proud to be incorporated as an organization with the Ministry of Corporate Affairs, registered with MSME, and approved by AICTE for internship programs. Also, our commitment to quality is underscored by ISO 9001 2015 certification, ensuring that every project we undertake reaches highest standards of excellence. Okay, thank you so much. That was all. Let us now stage our instructor and start today's session.
Good evening, everyone. My name is Harsh Pranjal, and I am a Django developer. So, Django is a basic, you can say, backend framework in Python, right? Okay. So, I have a question for all of you. Just please let me know how many of you are having Python as your first programming language. Yeah. Okay. Okay. So, I think you guys are familiar with VS Code, right? So, in this session, we are going to use VS Code as our IDE. Okay. These are few topics we are going to cover. These are some of our basic topics, and the yeah, on the day four, last day, we are going to touch up the OOPS concept, right? First of all, C++. Okay, C++ and Pythons are both are entirely two different languages. I mean, their structure are totally different. Okay, so now why we are learning Python, right? So right now, Python is in demand in the market, right? And there are a few features of Python because why Python is so popular. First of all, that Python is very beginner friendly. It is very easy to read, write, and understand, right? Another one is Python supports variety of operations, right? For example, you can use Python for machine learning, for AI development. You can use Python for web development, backend development. You can use Python for uh, data analysis, visualization, data science. You can use Python for software development and many more roles, right? Right now, Python doesn't contribute much in the Android development field, but I think sooner we will see some packages of Python which will contribute to the Android development also. Okay. Now there is one more you can say power of Python is that Python is open source. Now what is open source? Open source means it is free and available to everyone, right? So like C++ and Java, those are owned and maintained by some big companies. Like Java is maintained by Oracle, some part of C++ is maintained by Microsoft, some part is maintained by IBM and other like that. Yeah, for automation also we use Python, but in automation scenario, the most preferred library is Selenium with Java, right? Yeah, so Python is publicly available. So there is one advantage that Python is publicly available. So developers around the world can contribute to Python, right? See, Python is a programming language which is created by someone. So there are some people out there who are contributing to Python, here who are creating some Python code, right? Some packages, some libraries in Python. That's why Python, the community of Python is very big. Okay. Now come to interpreter and IDE setup. So to write a code, we need some setup, right? Some softwares where we can write code. One of the code editor everyone is familiar with is Microsoft Word, right? You can write Python code in Microsoft Word, but that is not, you can say, we cannot prefer that, right? We have multiple advanced option other than those simple word editors, right? One of the example is we have VS Code, another one is PyCharm, and one we have is Google Colab. Let me show you some examples. So first of all, to run Python in your system, you will need a Python interpreter. You can use this link to download the latest Python. Yeah, that's IDE. You can use this particular link to download the latest version of Python, right? One more example of IDE we have is Google Colab, and Colab is also one of the open source IDE provided by Google, right? And one of the advantage of using Colab is that there is no need to download anything to your system. Each and everything will run online in the Google server, right? Everything is online there, everything is set up for you. Okay. So there are some, again, there are some advantages of different IDs, right? Google Colab, it is mainly used for machine learning purpose, okay, developing machine learning models or deep learning models, right? Right now we are just going to use our simple Visual Studio Code. I think every one of you are familiar with VS Code, right? I just want you guys to install some plugins, one of which was Jupyter Cell Tags and Key Maps. Just install this Jupyter and it will install all other packages, right? Now, let's start with Python. So Jupyter is not a IDE, it is a notebook, right? There is a slight difference between a IDE and a notebook. IDE stands for Integrated Development Environment. Right? So, okay, we will see the difference soon. Let's start with our first program, right? See, there are two types of Python files we can create. One with extension .ipynb. It will create a Jupyter notebook for you. And one other extension is .py extension. It will create a Python script, a single Python file for you. Now okay, let me zoom this one. Yeah. So, so while using this test.py, a single Python script file, you can write only one Python code inside here, right? But in Jupyter Notebook, you can write multiple Python codes here, right? Multiple Python codes means multiple interrelated Python codes. Okay. Now I will be following the Jupyter Notebook, right? Okay. And let's start with our first code. So see, Python is very easy to read, write, and understand. So one, let's see. See, this is a simple Python syntax to print or write anything, right? To print a string in your display. Okay, a simple Python code, right? See, now you can this inside this print syntax, you can pass any type of string and it will print that string on the screen, right? This first line is printed by the first print statement. The second line is printed by the second print statement. Okay. Now, suppose your requirement is to create a Python code to add two numbers, right? So how we will do that? We will do that 10 plus 2 and it will add two numbers and it will print the result. If I will do 10 asterisk 2, it will print the multiplication. 10 divided by 2, it will print the quotient, right? Now, okay guys, just let me know what is the difference between an integer and a float. What is the difference between an integer and a float? Okay, see, see, integers are natural number, whole numbers, right? Represented as in your number line, right? We have seen -1 is an integer, 1, sorry, 0, 1, 2, 3, 4. All these are integers, right? And what are float? So decimal points, decimal values are float, right? So we have 2.3, this is a float. 6.7, this is a float. 6.77, this is again a float. There is one more data type that is known as double. Okay, so there is no big difference between the representation of a float and a double. Double is again the decimal values are known as double, right? Just the underlying difference between the decimal, the double, and float is that float is used to store small decimal values, right? But double is used to store very large decimal values. Okay, now see, as you can see that this 5.0, this is not an integer value, it is a float value. So this particular division, this is also known as float division, right? There is one more thing, one more operation in Python that is known as integer division. And for integer division we have 10 double 2, and it will print the value in integer format, right? Okay, after this we have the power. If you will use double asterisk, it will print base. The first one is your base raised to the power 2. Yeah, that is known as floor division only. So double asterisk, the format of using double asterisk is base double asterisk power, right? Yeah. Now, yeah, even very basic one, we also have a subtraction. Okay. Now guys, if you want to print the remainder, for that we will use modulo operator, right? So for this one, let me take 3. So 3 divided by 2, we will get the 1 as the remainder, right? So see, the output is 1. Okay, and if we will do 10, then the output will be 0, right? So these are different mathematical operations available in Python. Okay, now suppose let's talk about a concept which is known as variables. Now what are variables? Okay, before variables, let's talk about memory. See, whenever we run a single Python code, we get a memory in our RAM, a block of memory in our RAM. And this particular memory is divided into 5 subsections, right? And this happens with each and every type of programming language, right? Python, C++, Java. Each and every language run inside memory, and they require some special types of memory for their execution. Okay, so there are 5 subsections, right? Okay, so there is one subsection which is known as stack memory, right? And there is one subsection which is known as heap memory. Okay, we will discuss about the other memory parts, right? Container which contains the value, so it is using protection values. Yeah, and that is a good definition. Variables are was a container which contains the value. Now, okay, so there are basically we are going to discuss about two types of memory right now. One is known as stack memory, and another one is our dynamic memory, heap memory, right? So, suppose if you want to store some value, right? If you want to store some value, you will need a memory location, a box to store that value, right? And this box is created inside your RAM, right? This particular box will be created inside your RAM in this stack or in this heap memory. It depends on the implementation. Okay, right now we are looking for stack memory only. Okay, so this box is created inside your stack memory. Okay, and this box is known as the variable, right? This box is our variable. See, if I will do a equal to 10, now what I have done is that this a is a variable, okay, and this 10 is the value. Now what just variables are named, yeah, that is also correct. So what was created inside your memory, a memory box with value 10, and the name of this box is a, right? So this is how a variable is created in Python. Okay, so in Python, explicit declaration is allowed. Right. In Python, you can explicitly define a variable. Okay. Suppose I have created a variable b. Then again, what happened? There is some another box. Another box will be created with the value 20 in it inside the box, and the name of this box will be b. Right. So this is how you will create a variable. Right. And there are some, you can say, rules to create the name of a variable. So your variable name only contains alphabet, yeah, only alphabets, underscore, and numbers, right? So there is something, I cannot create a variable like this. This is not a correct variable name, right? It cannot contain parentheses. Okay, yeah, this is a correct variable name. My variable, this is a correct variable name. Okay, because underscore is allowed. One more thing, you cannot create a variable name starting with a number. It will again throw an error, right? You cannot create a variable name starting with a number, right? We can put a number after the character. The first character, the first letter of a variable can be an underscore or can be a character, but not a number, right? So we can also create something like this, my variable 2, and these both are two different variables. This one and this one are both two different variables, right? Now let's talk about something about we have different data types, right? Guys, am I audible? Okay, okay, okay. So let's talk about data types. There are multiple different various types of data types in Python, right? Let's talk about some primitive data types first. One is integer. We have just seen the integer type. Another one we have float. Another one we have string. Okay. There is no character data type in Python, right? So there is no character data type in Python. Okay. We have double. Then we have Boolean. Okay. There are another more different types of data types. We will see about that, but let's first discuss these. Okay. Now, so we have seen how to create an integer type variable. A is an integer type variable. Let's create a float type variable, right? Okay. Let's create a Boolean type variable. So Boolean contains only two values. Okay. That is true, and another one is false. Boolean contains only these two values. Okay. And notice one more thing, the f of the false and the true, t of the true, is always in capital, right? It is case sensitive. Okay. For string, see, we will discuss strings separately. Now, if you want to print the value of a variable, okay, if you want to print the value of the variable, inside the print statement, just pass the name of the variable. That's it, and it will print the value. Okay. One more thing you will do, print value of b is plus b, right? And we will, yeah, and we will get an error. So r maheshwari, uh, do you know why we are getting an error in this case? Okay, okay guys, we will discuss about this error right now. Let's first see how we will print in different formats. So value of b is, so these are two different types formattings to print a variable, right? One is you can directly use, no, I want the correct explanation for that, why we cannot use a plus operator. Yeah, string is concatenated. Good. Okay. So this f, right? There is a particular meaning of using this f. Okay, this f tells Python, the print statement, it tells the Python that this particular string, this particular value which is going to be printed is having some formatting. Okay, and that formatting is done by using curly braces. See, each and everything is printed as it is. Okay, this particular b is printed as b only. But if you will provide a curly braces, then the value of that particular variable will be printed, right? So this is some type of formatting you can use. Okay, one more type of formatting is that suppose I have a floating point, float value with some values like this, right? And I only want to print 7.89, nothing more than that, 7.89 only. So what I will do, print f value of e up to 2 decimal. And how to do that? Curly braces, the variable name e colon point to f, right? And it will print the particular variable with up to 2 decimal only, right? If I will use 3, it will print up to 3 decimals. Okay, okay, guys. And printing the Boolean value is again, there's not a big deal. You can just print C, it will print false. That's it. The value of C can be true and it will print true, right? Yeah, we can do replication. Okay, now let's discuss something about strings. Right. So let's create a string. Now this is a string. What is a string? So the definition, the correct definition for a string is combination of different characters, right? Okay. So this hello world is a string. Okay, and there are multiple ways in Python by which you can define a string. Suppose I have a my variable 2, and in this I will be using only single quotes, right? And this is a string. This is again a string. By using my variable 3, I can again define a string using triple quotes. Multi string. Now let's see why. See, there is no difference, no such difference between the strings which was created or initialized using single quotes or double quotes, right? There is no such difference. You can use anyone, right? But there is a, you can see a advantage of using triple quotes, right? Using double quotes or single quotes, you cannot define a multi-line string. Strings which can contain multiple lines, you cannot do that. It will throw an error. But using triple quotes, you can define a multi-line string. There will be no error, right? Print myvar to see. This is a multi-line string, right? We have provided the string in multiple lines. So that's why it is printed in multiple lines. This hello world is due to is the value of my var. This is a string, is the value of my var 2. Okay. Triple quotes is not treated as a comment. This hashtag is treated as a comment in Python. Okay. Now what is a comment? So comment are, you can define comment as the comment generally contains the definition, or you can say particular strings which can define the purpose of a code. It is generally used to express and to define the documentation of that code, why you are writing that code, what is the use of that code. And comments are ignored by Python. Python is not going to run this comment. Okay. Now guys, let me show you something. So we have a Python script. These codes are written inside Python script. Now, uh, our system can only understand Boolean values, right? 0 and 1, binary values. Our system, our CPU can only understand binary values. And we are writing our code in simple English, right? So how come this code will be converted? How come this code will be converted to a Boolean or 0 1 values, right? So there is a particular software, you can say a software, a system program running, which is converting this particular English code into 0 1 instructions, right? Let's see how Python execute these codes. Give me a second. See, just right now, Python is starting to interpret the Python code. Okay, there is a software program running in your system, in your Windows, right? That software program is known as interpreter. In case of Python, that is known as interpreter. The work, yeah, the work of the interpreter is to convert your Python code into binary format, line by line, each line at a time, a single line at a time, right? Right now, it is converting line one. Okay, as you can see, the particular our Python code is stuck at line one. Okay, and also guys, please see, right now none of the variables are created. There is not a single variable created right now. Why? Because our Python code is just right now interpreting, right? It's changing to the binary format. The first line is executed, and see, we have a my variable. A my variable is created in the memory with some value, which is hello world, right? After this, say line 2 is executed, my variable 2 is created in the memory with some variable, with some value, that is, this is a string. Again, my variable 3 is created in the memory. It is just right now created in the memory with some value, right? After that, print statement is printing the particular variable, which is my var, and the value was, okay, just let's execute this one again, and the value of my variable 2 is again printed, right? And the value of my variable 3 was printed. And see, after executing each and every line one after another, the code ends, right? The whole execution process ends there. Okay, so this is how a Python code is interpreted and is executed. Okay, so we have talked about strings, multi-line strings. Now, okay, in the strings only, suppose we have a variable 10 and we have a variable 50.6. If I will print a plus b, what will be the value that is printed on the screen? Okay, so this will be 60.6, right? We can add a float and a integer, right? This is simple maths, nothing to do with that. Now, if I will do print value of a plus b is equal to, and you can say that this particular line is printed in line number 1 and the another line is printed in a new line, right? Yeah, that's correct about compiling. Okay, so as you can see that this particular line is printed in line number 1 and this particular line is printed in line number 2, right? So how can you print each and every statement in a single line? So for that, the particular syntax is you have to define a end here, right, with space, and see what happens. Right now, the new line ended with a space. You have to define this particular end is known as parameter, right? We will talk about this in deep when we will discuss about functions, okay? But right now, just see the syntax, observe the syntax. This is how you can tell Python that not to end a line with new line character. Okay, see, this particular value is printed here. This particular string is printed by first print statement, and this print statement is printed by second. If again I will print e minus b here, this will be again printed on a new line. So for that we have to provide end here, end with comma space. Okay, this space is given here, right? And if I will remove the space, see, the space is removed from here. So by using this particular end, we are describing to the print statement that how to end the particular line, how to end a particular line. See, this line is again ended with in a separate line. The printing of this line is again started with a separate line, right? So we are defining to the particular print statement that how to end a new line. Okay. Now, right now I have used a word which is known as a new line. So these are known as escape sequences, and there are generally multiple types of escape sequences, that is forward slash n, r, a, and forward slash t. This r and a is of no use. Up till now I haven't used these two, right? There is no use, I mean no practical use of them, but we use forward slash n and forward slash t. See, what are these? So if I will do, see, there is no space between hello and world, right? There is no space between hello and world. But if I will put here a forward slash t, see what it will do? It will provide a tab. Tab is nothing but four spaces, four space, right? So it will provide a tab. So there is a special meaning for this forward slash t. And what is that? So forward slash t is used for tab, right? Now, okay. Now again, there is no space between this hello world. But if I will provide forward slash n, what happened? The forward slash n is used to change the line. This hello is printed in some other line, and this world will be printed in the next line. This forward slash n is used to change the line, right? Now, okay, so forward slash r is used to just rewrite that. Let's use print hello forward slash r world, and see, we will only get the world. What is the use of this forward slash r? So see what happens. Our print statement has printed this hello in the screen, right? It first printed that hello in the screen. Then what this forward slash r will do? it will see, okay, observe this cursor, this is blinking here, right? So if I will write hello and then again I will reset my cursor to the front, and after this I will start printing world. So this is the use of forward slash r. It will reset your cursor. Okay. If instead of world I will only print hi, say the output. Okay, it is giving me error because of this. Okay, see the output. Right, it is something weird, right? So what happened just right now? The print statement has printed hello. Then again, the particular cursor is reset to the front, the beginning, right? And what it's again start printing h I, and we get this particular string in the screen, right? So this is the use of forward slash r to reset the cursor. And forward slash a is used for bell, or you can say alert. If you guys are using speakers with your system, then you might be able to hear a particular beep in your system. Okay, it doesn't print anything, but it will beep for a second, or a, you can say, fraction of a second, right? So there are generally no use of this forward slash r and forward slash a. But you can observe one more thing. Whenever we are using this forward slash, it is used as a escape sequence, right? Okay, suppose that there is a need. Okay, there is a need to print hello world, right? And I want this quotes to be printed on the screen. I want this double quotes in my screen to be printed, right? So how we can do that? If I will print something like this, see, hello world is printed, that's well and good, but there are no quotes, right? If I will print this statement, see, here we have a single quote, right? So similarly, I want this double quotes to be printed here. Again, if I will print this using single quotes, right, we will get an error, right? So why this? I need these to be printed. For these scenarios where there are some special characters in your string and you want them to be printed, use forward slash to escape those sequences, escape those characters. Your print statement is not going to give any special priority to this particular quote, single quote, right? And you will easily print the particular values. Again, forward slash double quote, forward slash double quote, right? See, we have a double quote in our string. Now why this forward? See, if I will remove this forward slash, what is the meaning of this particular string? We have a string starting from 8 I and ending at T, another string starting from S and ending at game, right? Okay, but we don't want this, right? We want apostrophe S here. So we have to escape this particular single quote. Okay, so forward slash is used to escape a particular character, to change the meaning of that character, right? Okay, now there are multiple types of characters which may need to, where you need to use escape. See, uh, we have, okay, let me use a forward slash here, slash here, with that, okay, that's it. See, getting a tab. I have used forward slash t and I am getting a tab. and there are bunch of special characters inside here, right? And right now, if I will use a forward slash single quote, then again this particular single quote will be printed here, right? But I want to print this forward slash t. I want in my screen to print this forward slash t, right? In my screen, I want to print this forward slash and single quotes, right? So how to do that? See, right now we have seen an example using this f, right? The meaning of this is f is formatted string. It is telling the print, the Python, that the string we are going to print, sorry, the string we are going to print is having some special meaning to that, added to that. We are adding special meaning by using curly braces. We are adding the variable values by using curly braces. And with the help of this f, we are telling the Python that this string is containing some formatted values, right? Similar to that, we will use R here, right? R is used for raw strings. Okay, it is telling the Python that print the string as it is. There will be no changes in the string. Treat each and every particular symbol, special symbol, as a single character, not with so right now in this example, the Python is treating this forward slash as a escape sequence, right? But while we are using R, so R defines raw string. This particular forward slash is treated as a single character. Okay, not nothing with special meaning. That's why forward slash t is printed as it is. Forward slash single quote is printed as it is. Okay, so why we are discussing about this particular raw strings and formatted string, right? So we have seen the use of formatted string. Let me give you an example of a raw string. So if you guys then whenever you are searching about anything in a search bar or in your Google or chat GPT, wherever, there is a URL generated for that, right? The URL some of the times look like this. Let me give the particular, and we have some values. Some values like this, right? And suppose if you have created a Python code to print this URL or to parse this URL or to do whatever, to do some operation with this URL, and if you will print this URL, see, for this forward slash t, instead of printing that forward slash t, our Python has printed a tab there, right? So it is not a good practice to handle a URL like this, because a URL can contain anything, right? Any type of symbol or any type of particular values. So for that, we use R. And what R will do? It will format that to a raw value. And right now we are getting a particular correct URL, right? So this is just an example of using raw. Okay, and we have seen the example of using formatting, right? Okay, okay guys, let me know if you guys are having any doubts till now regarding print statement, raw strings, formatted strings, or different data types, Boolean, and all these. And we have also seen different types of mathematical operations in Python. Okay, now let's talk about comparison. See, Python is not platform independent. If I will write a code in Windows and I will write that particular Python script in particular, you can say, Ubuntu system, then that particular Python generated byte code, or the generated particular, you can say, the converted assembly code is not will not run in Ubuntu. Okay, so you can say Python script is platform independent. Yeah, so this is a particular good example of using a raw string for parsing a URL, right? Suppose, okay, consider scenario. I have given you a file, a particular file, MS Word file, Python virtual machine. Guys, those are, you can, for right now, those are a particular higher topics. Okay, we will discuss about Python virtual machines and pip, right? PPNV, virtual env, and conda, right? Just wait for that. Yeah. So raw string. Suppose if I will give you a particular MS Word file, right, and that file contains URL of different website, right, and your work, your task is to visit each and every website using Python and create some report, right? That particular scenario, this particular task is known as web scraping. In that case, you will need a raw string. Okay, a raw string to parse and work with each and different types of URL and different types of strings in that website, right? For that case, we will need R. Okay, and if you guys are heard about SQL, know the commands of SQL. So suppose we can run a SQL command using Python only, right? So suppose you have a SQL command something like this, right? This is a type of SQL command. Okay, so when you are running multiple types of SQL command with join operators, right? Table and join table 2 dot id. So these types of commands, it is preferred to run with a raw, as a formatted, not a formatted, a raw string. Yeah, so when we are, okay, let me go back to the variables. Yeah, suppose, see, when we have created a equal to 10, then and there the variable will contain 10. There is no other value than 10, right? If you will contain a equal to 2, right, this particular, this type of syntax, it is particularly known as definition and declaration, right? You have defined a variable a, right? You have declared a variable a and you have defined a value, you have initialized a value, right? The strings are immutable. Okay, but if I will create a variable like this, we will talk about this syntax, right? We will talk about this syntax. And right now, if I will print the value of b, see what we will get. We will get 0. We have not provided the value 0 to this b, but we are getting the output as 0, right? So what we will call this b, this b is our definition, right? We are defining a variable, right? We are declaring a variable, only declaring a variable, like there is a variable b, right? We are not initializing it, we are not providing any value, right? But this a equal to 2, this is a initialization of a variable. We are creating a variable a with value 2. Okay, and by default, if you are not providing values to any variable in Python, for int it will take 0. For Boolean type, for Boolean type and for string type, okay, we will talk about this syntax in detail, right? So we have C and we have my string. So by default, for a Boolean type, the value is false, And for my string, it is nothing, not even a single space. It is an empty string here, right? An empty string. A is equal to 3 and B is equal to what happens? Okay. Okay. Now, guys, we have a very good question here. A equal to B. Let's remove this one. See, if I will create a equal to 10, right? And if I will create a B equal to 10, right? So what are A and B? So A and B are nothing but a memory block in your RAM. Okay, basically in your RAM with some value 10. So each particular single memory block is having some address, which is known as memory address, right? For each single memory block, we are having some memory address, right? There is an address for your home. Similarly, there is an address for a single memory block. And that address, memory address, that particular memory address is represented in hexadecimal format, right? What is hexadecimal? So it will contain 0 to 9 and A to F. Okay. Now, how to create a hexadecimal value? So if you will initialize any value with 0x, it will convert that value to a hexadecimal number. Right. See, if I will print, see what we will get. Okay, let me take 12 only. See, instead of 12, we are getting 18. If I will only pass 0, okay, so it is giving error. Let me pass with small x and we are getting 18. So by using this 0x, you can define a hexadecimal value. Yeah, okay, just wait for that particular. Okay, so this is how you can define a hexadecimal values. Now we are having two different memories with some hexadecimal memory addresses, right? Now how can we print a hexadecimal memory address of a variable? So we will use a particular function, a particular syntax, id, which is known as id in Python, right? This id is used to print the memory address of a variable in binary format, not in hexadecimal, in binary format, right? It is not containing any x or y or z, right? F, something like that. So that's why it is in binary format. Okay. Okay. Notice one thing, right? So we have two variable a and b, right? And if I will print the id of b, what we will get? See, the values are exactly same. The values are exactly same. Okay. Now let's discuss how Python manages its variables. Okay, so Python creates a table, right? Generally known as lookup table. Okay, so there is a table in Python. Okay, separated in multiple rows and columns and blocks. Okay, this can be of multiple rows and multiple columns. Okay, now we have created two variables, right? A variable A and we have a variable B, right? Now what we have done, we have created a memory location and we have provided a value 10 to that. We have provided a value 10 to that. We have done that here, right? Suppose we are in, right now we are in our first line. So what Python will do, it will create a memory location and link both the memory location and the variable name together, right? Now see, for B, so B is again going to we are again going to create a particular memory location. We are again going to create a memory location and we are again assigning it with a value 10, right? So Python is not going to do this. And why? To save memory. Okay, this is how Python manages memory. Python is not going to create a new memory location and assigning the same exact value 10. What Python will do, it will link this particular B to the same exactly same memory location where A is linking, right? Right now, okay, let me remove this one and this one. A and B both are linked to the exactly same memory location. That's why when we are printing the ID, the memory location of A and B, we are getting the exactly same values, right? So uh, for memory management, for the scope of saving memory, Python will assign exactly same values to only a single memory location, and it will link two variables to that. Now, if I will perform any operation on B, suppose if I will perform B plus 1, right? The value of B plus 1 will be 11. And we are adding that 11 to B, right? Or suppose if I will be just suppose reassigning the value to B, right? And now if I will print the ID of B, see, when I have reassigned the value, the memory location of B changes. Now, how things work here, right? So in the background, so we have seen that this new memory location is not created, right? Okay. So in the beginning, what happens? B is linking to this memory location only, right? But right now, what we have done, we are doing some operation with B. So whenever we are doing some operation with B, then Python will create a new memory location for B, okay, and erase this linking, right? It is only done by Python, right? Right? Erase the linking, then link the value to the new memory location, right? And what we have done, so we have reassigned the value, we have updated the value from 10 to 20, right? So this is how Python manages memory. Okay. Now, this assigning thing, assigning the variable name to the exact same memory location, assigning two variable to the same memory location, it depends on the it depends on the interpreter, the Python you are using. It depends on the Python, right? So if I will create two strings, my string 1 with the exact same value and my string 2 with the exact same value, what happens? See, in this case, we are again getting exactly same values, but it depends upon the Python. In some of your machines, you maybe not getting the exactly same values, right? But it depends on the interpreter, the Python, whether to assign the same exactly same memory location or not, right? If I will do any change to any of one of the variables, suppose if I will do, so this is only a concatenation operation, right? Okay, so we will discuss about this operation. Okay? Just right now observe the ID and the memory. See, the memory changes, right? So if you are having two variables with exactly same values, to optimize memory, the Python interpreter may assign the same memory to the different variables, right? But if you are doing some operation with any of the variable, Python will take care of that. It will create a new copy memory and will do the variable for you. What's your string 1 and string 2 is at different locations. See, string 1 and string 2 are exactly in same location. After the operation, when we have done the operation with string 2, or if you will perform the operation with string 1, then the values, then the location will change, right? Yeah, logically both of them should get the different memory location, but Python will you can say that optimize the memory, right? Yes, Ali, we can do that, but that is not a correct syntax. right? This will be a correct syntax. We will get the value as 4 as 4, right? No, string is immutable in Python. Integer is also immutable in Python, right? This particular syntax, which I have just written right now using this comma operator, this is known as tuple unpacking, and we will again discuss this in future, right, in our next session. Okay. Right now, just let me know, are you guys comfortable with this memory concept? How Python saves memory in this case? Right? How Python saves memory in this case? And what are raw strings, hexadecimal format, all these. Okay. Now, guys, be very careful with this particular memory assignment and referencing to the same memory block. This is you can say it is very good for memory management, but this will raise to a very, you can say that, a very keen error in Python, right? We will see a particular flaw where Python does this to save memory, but we are getting a particular logical error, right? Okay, let's discuss about we are going to, yeah. Now, there was a question, what happens if I will define a equal to, sorry, a equal to 10 and I will do b equal to a, right? Okay, just let me know, only by using only pen and paper, right? Please don't compile this one. What will be the output of these two print statements? Will we get two different memory location or same memory location? The memory locations are same, so it will not be different. See, guys, this, you can say that this is a advanced version of this problem, advanced version of this question. Right now, what we have done, we have directly assigning the a to b, right? We are directly assigning a to b. That's why we are getting same memory locations. Okay. Similarly, if I will do, where we have, if I will do this, yeah, then again we will get the same memory locations, right? See, you are only answering your question, right? How we know that string 1 and string 2 are two different strings? You are using two different variable names, string 1 and string 2. That's why it is bound to be two different strings, right? Their value may be same, but if you are using two different variables named string 1 and string 2, they will be treated as two different strings, right? Okay. Okay, guys, let's discuss about mutable and immutable in Python, right? We will better understand this in the explanation of this question. So we have, okay, so we have, okay, we have not seen any mutable data types right now. Let's talk about immutable in Python. So immutable data types int, string, and we have character. There is no character, float, double. All these are immutable data types in Python. Now, what is immutable? Immutable is many of you or many of the answers I have seen that immutable variables means we cannot change the value of a variable, right? That is not the correct definition. See, the value of a is 10, but I can change the value of a to 20. There is no problem with that. Values can be modified by creating an object. That is again not a pinpoint definition, right? So again, I can print a and the value will be 10 and the value will be 20. But again, integer and immutable. So there is the definition of this immutable part is related to how memory is managed, how we create memory. So suppose, see, this is a particular memory block and I have a variable here 10, right? If I am able to change this particular 10 to 11, right? If I am able to change this particular 10 to 11 inside this memory block only, then this particular variable is known as mutable variable. We are changing the variable, the value inside the same memory block, right? That is known as mutable, right? And what is immutable? So see, a very good example, value is not changed after declaring variable that is constant. That is the definition of constant. So yeah, only this variable. See, if I will print the id of a in this case, and if I will print the id of a in this case, we will get two different IDs. So any conclusion after this observation, we are getting two different IDs for two different values. Any conclusion on this? So value is not changed after declaring variable. That is the definition of a constant variable type. There is nothing to do with immutability, right? Immutable variables are something else. Yeah, tuples are immutable. Strings, integer, float. Okay, see, so we have a variable a, right? And for this a, we have some memory location assigned with some value, suppose 10, right? And a is pointing to this memory location. Instead of pointing, the technical term is referencing, right? Referencing to this memory location, link with this memory location, right? Now, so what is this particular, the first memory address? It is the memory address of this 10. Okay. Now what we are doing? We are again reassigning a with the value 20. So what Python will do? It will create a new memory location. It will create a new memory location with value 20. It will delete this link, delete this reference, and again reference the value, again link a to this 20, right? So here the value is modified. The value of a, earlier the value of a was 10, right now the value of a is 20. So the value is modified, but how the value is modified? We are right now referencing to some new memory location, right? So this will be the correct key point. What we have, the address could not affect when you change the value is known as mutable. If the modification value affects the address, the variable is, yeah. That is the correct definition of immutable and mutability in Python, right? So this is typically what happens when you define or operates with integer or float or strings. See, I have 20, right? So let me know what will be the what happens if I will print the value of a in this case. After this operation, what will be the output of this a? Print a. What will be the output of this a? Give me a second. Yeah. So the value will be 22, right? And how this particular operation will perform by Python. So what Python will do? Python will fetch this 20, right? Okay. Python will perform addition operation, right? And the value, the combined result is again created. A new memory location will be created, and that combined result will be provided to that memory location initialized, right? This old reference will be deleted and this new reference will be created. Yeah, but change in memory location. So see, the memory location again changes. So this is how you can conclude that integer, string, tuple, or you can say that what we have float are immutable in Python, right? Okay, I think it's pretty clear now. Okay, so let's talk about comparison operators. We have greater than, we have less than, greater than equal to, less than equal to. We have not equal to, and in comparison, when we are comparing two variables or comparing two values, we use double equal to, right? When we are comparing for equal comparison. Now, see, A is 10, A is 10, B is 20, right? Okay, guys, tell me what will be the value. So if I will do A, B is greater than A, what will be the result? A true or false? It will be true or false. Okay, so before commenting on the memory status of set, you have to understand how set is implemented in Python. Set is implemented using dictionary or tuple or some other. Yeah, so the value will be true. And if I will print, so we will get true, right? This one, okay, um, don't. Yeah. Okay, guys, just comment out the output of all these print statements and is use only pen and copy. Don't compile these. Okay, so in this case, for this particular statement where b is equal to a, right? We are getting an error, right? We're not getting the value as 10, but we are getting an error, right? And why we are getting an error? So we will surely discuss about this particular value, this particular error, but not right now, because this error is generated as there is something known as targeted function calls in Python. Okay. Yeah. Other one is this particular last one is true. Okay. So now suppose we have seen, let's work with type conversion. Guys, any doubt in the previous example, this comparison example? System is okay. Now let's work with type conversion. So suppose I have a value, integer type value, right? Again, I have a float type value. So I can convert this integer value to a float type, right? How to convert that? So float, the variable name a, and if I will print c, it will be printed as 10.0. If we want to check the type of any variable, both values, no, we are not getting this error because of both values are not same. This is something to do with the function call in Python, right? Okay. Yeah, we will use type, print the type of a variable. Say it is printing float. Okay, so type of c will be float. Now if I will convert this b into int, and if I will print type of d and the value of d, anyone tell me what will be the value of this d? Okay, see, we will get the value as 50 only. Why? Because we are typecasting 50.989 whatever that is to integer type. And during typecasting, what happens? The integer will only store the integer value and it will discard the particular decimal values. Okay, right. Okay, so there is a particular technical term which is used when you are casting integer to a float. See, okay, so it is pretty, you can understand that integer is a lower value and you are typecasting it to float, which is a higher value, right? So that is a particular technical word used for lower to higher typecasting and higher to lower typecasting. Here b is a float value and we are typecasting it to int, right? So anyone knows that particular technical keywords? Lower to higher typecasting and higher to lower typecasting. Okay, consider that as your homework, right? Study about that, because that is a, you can say that that is a very crucial concept, typecasting. Okay. Yeah, so again, suppose I have a string and name of that string is hello, the value of that string is hello, and what I am doing, I am typecasting that string to integer and I am printing the value of a. See, in this case I will get an error. It is not allowed to typecast an integer, a string, to an integer, right? It is not possible. Not allowed is not a good word. It is not possible to convert a string to an integer. So explicit and implicit typecasting. Okay, we will discuss about that again. Those are again two. Nah, those are not the correct keyword which I am looking for. Right, that are some different concept. Yeah. So as you can see that we cannot convert a string to an integer type. But suppose if I have a string, a special type of string which only contains digit, not even a single space, not any other character other than digit, right? This type of integer, sorry, this type of strings can be converted to integer, right? If you will type print the type of a, right? So the type is integer, okay? Now, if I will provide a space here, there will be no problem, right? If I will provide a space in between, see, we will be getting an error, right? And if I will provide an underscore, in this case also we will be getting an error. So it is safe to assume that or say that the string should only contain digits, okay? Not any other particular character than that. Instead of int, you can again convert that to float also, no problem with that, right? Let's see if we will do this to double or not. Now guys, tell me, we will get an error for this case or it will compile and we will get a double format here. Also one more thing. Okay, first, this case. In this case, we will get an error. And why? So double is not defined. But we have seen that there is a double particular double data type in Python, right? But we cannot typecast a double. So how come double is a data type in Python if we cannot typecast or we cannot define a double value? See, it is not a double value. We are getting a error. If I will remove this L, we will be getting float. Small L also not works here, right? So these are some different, you can say, compile time. Yeah. So these are different types of syntax which will be used in different languages to define a double. But in this case, we are not able to define a double in Python. Yeah, it is again possible. See, okay, in this case, see, observe the output, right? If you are providing a very large value to be converted to float or to be converted, let's take int, right? To be converted to int or to be converted to float, right? So that particular large values may not be converted safely. Okay, so int is again overflowing. Let me take float. So that particular large values may not be converted as exactly to its integer or particular long, yeah, long values. Yeah, right. So long values cannot be converted as exactly into float or into integer, right? So that is something to be taken care of. Okay. Now guys, observe one more thing. See, this is a very large value. Okay. And why we are getting some other output here, like what we are getting 1e plus 35. Why we are getting this? So come back to our memory implementation only. Suppose this is your box, right? And you have to store a very large number inside this box, and the size of this box is not enough to put that to store that large number. So how to store that large number? What Python will do, it will convert that number to the 10 to the power, right? Suppose 100 will be converted 10 to the power 2, 11 will be converted 10 to the power 1 plus 1, something like that. So again, this particular very large value will be converted to the 10 to the power something and then plus 35. See, what is this particular notation? Suppose if you have to define a particular value with 10 to the power 6 or 16 or 10 to the power 9, something like that, you can use 1e9. And if I will print the value of a, what we will get? 10 to the power 9. So it is float. We have to convert that to int and we will get the integer type. And if you will not convert that to int, you will get the floating type 9, or you can put 19 and we will get 10 to the power. So it is not printing here right now. Let me convert that to int and it will print the particular value, right? So this very large number, right? 10 to the power 19 is very large number. So converting this type of large number and dealing with this type of large number, you have to be, right, very careful with these. Okay. Now, okay, guys, any doubts up till now? Okay, so we have explicit and implicit typecasting, right? So I have a equal to 20. Okay, 20.10. And if I will convert that 20 to an integer, suppose I have a b is equal to 10 and I have c is equal to a plus b, and I have to print c and print type of c. Okay, tell me the data type of c, what this will print, and use pen and paper only, right? What will be the output of this c? So the data type of c will be float, right? Okay, but we have not defined the data type of c as float. Okay, we have not defined the data type of c as float, and we have not provided any float value, right? Then how come c is getting the float? So see what happens with Python and what is implicit typecasting. Suppose you have a float value, right? We have value like 1.1, right? And we are adding this 1.1 with value 1, or let take 12. So Python is not going to perform this operation like this. It is not going to add 1.1 and 12. What Python will do, it will add 1.1 and 12.0. This conversion, this particular conversion of 12 to 12.0, or in this case the conversion of 10 from 10 to 10.0. See what will happen here. C will be taken as 20.10, B will be taken as 10.0, right? This conversion of 10 to 10.0, it is done by Python, right? This conversion is done by Python. So this is known as implicit conversion, right? And in this case, the conversion which is done by the user, that is known as explicit conversion. So that's why, in this case we are not adding an integer and a float. In this case, we are adding a float and a float. That's why the output is always a float, unless until you will provide an explicit typecasting. In this case, you will get an integer. Other than that, you will get a float, right? Okay, look out for this type of conversions from 10 to 10.0. Again, this type of conversion, converting an int to a float to a higher value, there is a certain keyword, right? Search for that keyword, right? We will discuss about that keyword in tomorrow's session. Just a simple thing, just two keywords, nothing that. Go back to this. Okay, now let's say Boolean comparison and Boolean operations in Python, right? So guys, we have seen that a is equal to 10 and b is equal to 20. Okay, now tell me, if we have a true statement and we are performing AND operation with that true statement, what we will get? What will be the output? Same with false and true. Same with true or false and true or true. Yeah, for this one it will be true. For this one it will be false, true, and again true. Right? So suppose I will ask you, is the question is B is greater than A and and A is greater than 0. If you have to check this particular condition, right? So for this, the correct syntax will be, instead of and, the symbol and, we will be using the keyword and. In Python, there is a keyword and, right? Okay. And let's print the type return value and we will get true, right? If I will print A is greater than B or A is not equal to 50, right? Let me know the output of this particular last line. Okay, so Gautam, we have discussed this particular operation, right? When we are discussing about the mathematical operations in Python. So, yeah, see, single division is used for float division. We will get the output as float. When you want integer division, use two division symbols, two division operator, right? Double division, or is it also known as integer division or float division, right? So use double division. Okay, so in this case, we will get again true, because for or type of condition, any single condition in true will result in a true, right? This is nothing but a truth table, right, guys? A very basic thing. Okay. Now, so for comparison, we will use and or, the keyword and or, right? But for bitwise operation, now what is a bitwise operation? If I have, see, okay, let me know what is the binary representation of 3? I have a value decimal 3. What will be the binary representation of 3? So the binary representation of 3 will be 110. The binary representation of 2 will be 010, right? And if we are performing an AND operation, right? If we are performing an AND operation, the result we will get as 100. If we are performing an OR operation, we will be getting output as 110, right? Yeah. No, not the same syntax for XOR. See, here we are using comparison, right? Comparing two particular values for performing bitwise operation like AND, OR, and XOR. XOR is a bitwise operation, not a comparison. It is a bitwise operation. Okay. For XOR, the value of the XOR of 1 and 2 will be 1, 0, 0. Right? Okay. Now, how to perform this in program? So we have a equal to 3, we have b equal to 2, right? Just print the value of a. Here we are using AND, right? Why? Because we have to perform a bitwise operation, bitwise AND, right? So the symbol AND is used for bitwise AND, and for comparisons we use the keyword AND. So let me remove this one. Use AND here. Right? For Boolean comparisons, we use and or keyword, but for bitwise operations, we use the symbols, right? And print the value of A operation or B, print the value of A XOR B, right? And the output are 2, 3, 1. Say the binary representation of this is 2, sorry, this one is 1, right? What will be the binary? Yeah, that will be 2, this will be 3, this will be the XOR value we are getting 1. Uh, the XOR value we are getting 1. Okay. Let's first discuss about these two. So we have seen the and or operator at bitwise and bitwise or. There is no difference. The same thing will be used here, right? For XOR, use this particular symbol, right? And in this case, we are getting 1. Right, okay, let me change the values a little bit. If we have A as 10 and if we have B as 5. Okay, so what will be the binary representation of 10? Right, 4, 2, 1, right? And for 5, what will the answer of NOR? See, we have to create an expression for NOR, right? There is no predefined operator in Python or in any language for performing a NOR operation. You have to create a particular, that is known as singleton automata or NOR machine, right? You have to create that. You have to use these expressions to get a NOR, right? What will the answer of 5 and 7? See, let's perform this operation first. Okay, so we have 5, 8, 0, 4, 1, 2, 0, and we have 5, right? If we will perform XOR in this case, what we will get? 1, 1, 1, 1, 1, right? Let's see. Yes, we have 15. Yeah, that is correct. And why in this case we are getting, Guys, any idea why we are getting 1 here? I think I have done the XOR operation correct, right? For this particular values. Oh, sorry, the value of 3 I have taken, that one is wrong. Sorry, this one is wrong. Okay, my fault. This will be 0. No, this will be 1, 0. No changes in that. This will be 0. This will be 1. The value will be 3. And this will be 1. Okay. Yeah, now it's good. Okay, any doubts in last one 3 binary representation is 0, 1, 1. Yeah, I've done that wrong. I think the value of 5, 0, sorry, 1, 2, 4, 8. That's correct. That value is for 6. 4 plus 2, 6. See, the last bit is for 1, right? The last bit is one for 1, second last 2, then 4, then 8. Right? Okay, guys. Now observe one thing. This A, this A is converted to its binary representation. This B will be converted to its binary representation, and then the AND operation, bitwise AND operation was performed. This conversion of integer to binary format, right? This conversion of an integer to binary format, it is not an implicit conversion. It is not an implicit conversion, right? It is not really converting 3 to binary format. Why? Because see, we have seen this memory, right? We have seen that data are stored in memory, and memories are nothing but boxes, right? Variables are nothing but boxes. If you have a value 2 inside this box, 2 is not stored inside this box. Inside this box, 0, 1 and 0 will be stored, right? So this is how the values are stored inside memory, in always in binary format, not in decimal, always in binary format, right? Yeah, yeah. In this case, see, if consider this case, right? We have a case here 5 and 7 and 0, right? If you guys are taking any notes, right? If you guys are taking any notes, write down this one thing. Any value other than 0, null or false is treated as true. Any value other than 0, null and false is treated as true. So if I will print output of this, it will be considered as 0. 0 means false. And why this? See, what will be the output of this? True and false. What will be the output of this? Okay, always start from left hand side, or if you want, you can perform the operation from right hand side. No problem with AND operator. But AND operator always perform operation from right hand side, sorry, left hand side, right? So true and true, it will combine and it will result the value as true, right? Now again the operation will be true and false, and for this the value will be false, and we are getting the value as false, right? If you will convert this to Boolean inside here only, right, we will get the value as false. Okay. Okay, so always remember one thing, any value other than 0, null and false is always treated as true, right? This 5 is treated as true, this 7 is treated as true, but this 0 will be treated as false. So from this one, you will get the value as 7, right? So what is 7? 7 is nothing but true. Okay, 7 is nothing but true, right? Now, if you will ask why we are getting 7 and why we are getting 0, so that is nothing but the last value of your true operator. If you will perform 7 and 5, see what we will get. We will get the value as 5. Yes, 5 is also true. 5 is also true. 7 is also true. Okay, how? Okay, think of the same scenario, right? This is your memory block for holding a true statement or a false statement, right? A true or false, a Boolean value. What do you think? What is stored inside this? 0, either 0 or 1, right? Right? So 5 is always treated as 1, 7 will be always treated as 1, but 0 will be always treated as 0, false. Okay. And why we are getting 5 and why we are getting 0? So the last expression which is being evaluated using and the last value, that is the output here in this case, right? Again, if you want to check, suppose if you want to check the that some particular value is boolean, sorry, the particular value is true or not. Suppose I want to check 2 into 4, it is true or false, so we will get true. So you can check using this. Okay, so in this case, and see, we will get the value as 0, that will be false, right? So guys, the only the concept is here, everything is treated as true other than, so other than 0, false and null, right? And you can play with it, right? You can add multiple and or operators, brackets and all these things, right? So every coding language follows BODMAS rule, right? So if I will put a or here and if I will put a bracket there, right? In this case, we will get true, right? Because this statement results in true and the whole statements result in true, right? So, okay. Okay, so we have covered bitwise operations, comparison. We have also seen type conversion, comparison operators, immutability, mutable formats, memory management, raw strings formatted. Yeah, let me show you some other formatting values. Okay. So suppose we have a value like this, and if I will print value of a is curly braces a, right? If I will provide a comma like this, see, again the value is changed in this particular format. Again the particular values are changing. So this is how a particular this is also a correct format, right? You cannot say that we will get a compilation error in this case. Okay, but say the type of a, the type of a is changed from integer to tuple. Tuple is again a data type in Python. We will discuss about tuple list and dictionary tomorrow, right? But again it is changed. So suppose you want to print a particular variable. Okay, just let me give you the whole booklet only, right? Hmm, I think I have it here. Okay, guys, I will provide you a particular notes, right, on formatting. So you can perform different types of formatting here. We have seen the dot one, right, for float. So suppose if I have some 4 here and let's put a dot here, and we have seen 2f. Okay. We also have, okay, let me tell you one more thing, one more data type in Python. It is not, and you can say, primitive data type. It is not actually defined in Python, right? But we can use it. That is date and time. Okay. And it is imported from a library. Right. So what is this particular statement? What is the meaning of this particular statement? Okay. So consider a scenario where your friend has written a very vast code, right, which performs some operations, okay, and the output of that operation is particularly memory related, or some output is there, right? Consider some output is there, and you are again creating a very huge code, right, around thousands of lines of code, and you need that output, you need the output of your friend's code. So what you will do, you will import that code, import that output, right? And that is what known as from so that is what known as the particular libraries and modules. So we have sqrt a. What it will do, it will print the square root of a. Now, what is the particular concept behind the calculating the square root? That concept is written inside this math.py file, sorry, py file. Okay, observe this extension. The file extension is pyi. Right? It is a Python file, but it is a binary generated Python file, a pre-compiled Python file, right? And here somewhere we may have the implementation of square root. See, this particular function here, the concept of how to calculate a square root, how to calculate the square root of a particular variable is written here, right? The concept, the particular formula, and we are using that formula directly in our into our code, right? So here math is considered as module, right? Or in other languages it is also considered as library, right? And square root, it is a function defined inside module, math module. You can say math library. Let's use the word library for now. Okay. Now, how to use a particular module and how to use a function from that particular module. So for that, the syntax will be from keyword, from module name, import function name, the function you want. Suppose there is something known as floor, right? And if I will do b is equal to 20.98, and if I will print the floor value of b, what we will get? We will get 20, right? That is the floor value of b, right? So this is a very good practice to import a particular library into your code, right? The library, from library name, and import specific functions, the functions you need, right? Now there are other syntax also. For example, you can also do import math. This is also defined, means this is also legal, there is no error in this. or from math, import asterisk. Now, what is the meaning of this from math import asterisk? So asterisk is defined to import each and every function which is present inside the math Python file, right? All these functions will be imported, right? All this whatever you will see here, all 128, I think there are 20 or 22, something like all these log formulas and this sign remainder, all these functions will be imported, right? And there is no need for that, right? If you are only using square root or floor, then there is no need to import the whole math, the all the functions from math. And import math, it will do the exactly same thing. It will, instead of importing the all the functions, it will import the module itself, right? It will import the module itself, right? So if now I have a value 20 and I want to perform square root on this, so now sqrt won't work, right? In this case sqrt won't work, right? If I will comment out this, in this case sqrt won't work, right? Okay, and we are getting some values, I think math. Okay, so in this case square root won't work, right? We are getting some values here. Again we will discuss about that, right? Because square root is embedded with Python, sorry, math module is embedded with Python. There is no need to import math module in Jupyter Notebooks. Now in this case, if you are importing a module using import, using this particular syntax, and you want to use a function of that module, use the module name, dot operator, and the function, right? So sorry, if you are using import module name, then in this case use module dot function name to use that function, right? Or in this case you are directly importing the function itself, so there is no need to use module name dot function, right? Okay guys, so that's it for today, right? We will discuss about more data types tomorrow, right? And we will discuss about loops and many more concepts of Python. Up till then, revise all these things and I will provide you these codes, right? So then